Hello there, and welcome on the LabHub. So today we're gonna talk about the inclined planes, and we'll start with the basics. This is inclined plane. Oh, sorry. This is an inclined plane, or you can call ramp or whatever you want. But we don't usually use a single ramp without any objects on it. So, in context of physics, we need some block or some ball, but usually it's a block. So some object that lies on a ramp. So let it be block, and it's not just stays, right? It has some mass. It's on a planet called Earth, so it has some gravitational force applied on it, right? Yep. And important to notice, the gravitational force is always perpendicular to the Earth, not to the ramp. But what is perpendicular to the ramp? Right, perpendicular force. And it represented like this. And it also equals to the normal force. And if you don't apply any force, like on y-intercept, they both will equal 0, right? And here, we can easily find another force. This one is called a parallel force. And it's similar as this force. This is Fg, or force of the gravity, because this force was caused by the gravity, because an object moves downwards due to gravity. However, it can just go through the ramp, right? So it goes like this. And it's not going to be so easy. There is no frictionless surfaces in a real world, right? Even the ice. So, what is the friction? Friction is the opposite force for this one. Or, if you are going upwards, this is gotta be the friction. So friction is the opposite force. In our case, it goes downwards, right? Oh, it goes backwards. So this is the force of the friction. And now we got this weird figure. We can find some formulas for it, which we will use in the future problems. And one important addition, here is the angle we will work with. This is the most important angle in the whole inclined planes problems. So we will work only with this one. So we'll start with the friction. This is the easiest one thing. Force of the friction equal to mu Fn, right? However, there is another formula we will represent, but now we need to know that this is also sin of the angle times mg, right? So how can we find mu? This is something like a new parameter. We're breaking down it all in the beginning lessons. So mu, in our case, equals to sin of the angle mg divided by the net force. What also equals to sin of the angle mg divided by cos of the angle mg, which means sin of the angle divided by cos of the angle. And the amount will be really really, really small, because usually mu is not more than 1. It's always like around 0.3, 0.4. It's a usual thing. So don't be scared if you got something like 0.3312. It's not a problem. It's all right. So, all right, we figured out about the friction force. What about another things? As I said before, if you don't apply any force like upwards on y-intercept, Fn is got to be equal 0. And this thing, F perpendicular, will equal 0 too. So what maybe can we find more? What about this force? This is Fg, right? How can we find it? Or maybe how can we find all the forces applied on the object? Like at the moment, all the forces, like some of them. Now I need you to know, and I want to introduce a new sign called sigma. Sigma is it's a sum of all the forces applied, or of all anything applied on some object. It's in general physics, but in our case, it's all the forces applied here. So let's break down it for the y-intercept. Sigma Fy equal to net force minus cos of the angle Fg. So this is the y force. And as you can see, this is also the gravitational force. We can represent it as mg, or I represent it like this. So yeah, it goes down. So that's why we use it in a formula of sum of all y forces. That's why it's not 0. Because yeah, F is equal to 0, but Fg not. What about sum of the x forces on this intercept? Sigma again, Fx equal to sin of the angle Fg. Why? Because this Fg is also applied on an x-intercept. It's not only going downward straight, right? It helps object to go down on the ramp, but its coordinate on an x-intercept is also changes. So it was here, right? It goes down. Let me use another color. It was here. It goes down, right? So it was at 0, right? It goes down, and eventually will be on x equal to 5, right? So it changed. That's why we use Fg here also. Minus force of the friction. Again, because this is the opposite force, and it were caused by contacting of the box with some surface. In our case, it's a ramp. So in general, this is all you need to know about the friction force and inclined planes. Let me clear it up to you to make it more understandable.